Hello there, Year 6s, it's Mr. Conway here. Now for today's how-to guide, this is to help with your maths lesson today, and it's to try and calculate missing numbers, okay? Now I have a question here, and this is one of the same questions that you have in your PowerPoint for today, and I thought we'd work together on this, okay? So let's read this question before we start doing anything first of all. It says, and it's a little bit pixelated because I've had to make it a little bit bigger for us today. The question says this: I have a secret number. Ooh. Now I multiply my secret number by 3 and add 7. This makes a whole number in the 20s, but any number that is 20 and including 20 to 29. So the answer could be 20, 21, 22, 23, 24, 25, 26, 27, 28 or 29. The question is this though: what could my secret number be? Find all the possible values for the secret number. Now, because it says find all the possible values, this is telling me, right, Mr. Conway, there's going to be more than one answer to this. So let's have a look at just deconstructing this question first of all. And when you are deconstructing a question like this, start from the beginning and let's figure out the information we already know. I have a secret number. Right, so this is what I need to figure out, the secret number. Now, because I've been working a lot with algebra lately, what I'm going to do is I'm going to say my secret number is going to be the letter S. It's going to be the letter S. I don't know what it is, but I'm going to replace that random number, any number, with the letter S. So what do I do with this letter S? I multiply my secret number, so there's the S again, my secret number by 3. So if I think about my function machine, S goes in, and I need to multiply by 3. Multiply by 3. Right, what's the next step to my function? And add 7. Okay, so I'm going to add 7. This makes, so my total, this makes a whole number in the 20s. So it's going to give me an answer that's anywhere, including 20, but from 20 to 29. You'll notice that I've now converted these sentences into an algebraic formula. Let's see if we can simplify this a step further. So if S goes in, remember on a previous video we did discuss when you multiply a letter, an algebraic letter by a number, we can't put them together. We can't just do S times 3 because that looks like x3 and it looks a little bit funny if we do something like that. So we omit the times table sign and we simply put S3. So I'm going to put here S3. What's the next step I need to do? The next function is to add 7, so S3 plus 7, and that is going to equal any number that is including 20, but from 20 to 29. Right, so now I've got my algebraic formula. I can now start having a go at experimenting and seeing, well, what does S equal? Because that's ultimately what I'm going to put here. What does S equal? That's what I'm trying to calculate. And remember, find all the possible values. There's lots of different answers for this, okay? So to kind of tackle and explore this kind of question, I'm going to be using a bar model, okay? So if I took this algebraic expression and turned into a bar model, it would look like this. 3 lots of S plus 7. Okay, so I'm going to draw a bar. I'm going to draw a bar underneath because I'll need that in a second too. So I'm going to have 3 lots of S. So that's S, S, S plus 7. And the total of this bar, so S plus S plus S plus 7, is going to be any number between 20 and including 20 to 29. Okay, so now I know what I'm doing. Let's have a go at seeing if we can figure out what S might equal. I'll use a black pen for this one. So I'm going to go with, you know what, I'm going to do some substitution here. I'm going to say for my first example, S is going to equal 1. Okay, so I'm going to redraw this bar, but instead of putting S, I'm going to substitute it for the number 1. So I'm going to draw my bar again underneath. And I'm going to have, and I'm going to still put my 7 in there, but instead of S, I'm going to put the number 1, 1, 1, 1. So 1 plus 1 plus 1, that's 1, 2, 3, plus 7 is 10. Now then, does S, the secret number, equal 1? Well, absolutely not, because the total is 10. But my total needs to be any number between 20 and 29. Right, so I am way off here. Right, so I'm going to have another go. You notice a bit of trial and error here. Well, what if, well, 1 was quite significantly less. I'm going to do it over here this time. I'm going to say S equals, the secret number is going to be 5. Right, let's see what the success is with number 5. So I'm going to draw my bar again, just like this one. And I'm going to substitute S for the letter 5 this time. So it's going to be 5, 5, 5, and 7. 5 plus 5 plus 5, 5, 10, 15, plus 7 is 22. Hey! Is 22 in between and including 20 and 29? Yes, it is. So 5 is one of our possible secret numbers. Now then, there's a whole list of numbers. I got to 22, but I've actually missed out 20 and 21 here. So it's now over to you guys. What else could S equal so that the bottom of your bar, the total, is a number from 20 and including 20 to 29? There's quite a lot of different answers. 5 is just one of them. Why don't you try next, just to get you going, what if S equals 6? What would you get then? Right then, Year 6s, enjoy your algebra, enjoy being a detective once again, and tell me all the different solutions you can find for a secret number. All right then, Year 6s, I hope you have a really lovely day, and I'll see you again soon. Goodbye now.